In this video, we're going to use the calculator to graph a derivative. So we've already going to find the individual value of a derivative. Now we actually want to graph the whole thing. All right, so some asks you to interpret the graph derivative. If it asks when is this original function, when is it increasing, you need to find the derivative and figure out when the derivative is bigger than 0. All right, so we need to look at the derivative graph to see when it's bigger than 0 above the x-axis. So looking at the derivative graph is a useful thing to do for certain questions. And again, you want to avoid taking the derivative by hand and then plugging in, because a lot of these times if they're putting it on the calculator section, it's a complicated derivative. It is something you could do by hand, but it might be like a double product rule question, or there's a really long chain rule. A lot of places where you can mess up, especially when you're typing in the calculator with parentheses and things. So we want the calculator to do as much as possible. All right, so how are we going to do this? We already saw how to find the derivative at a point using the end derivative button. The only difference is instead of putting in a number, we're going to tell it to do it at every x. So pretty much the only difference is that last part of finding the derivative using end derivative, we just put in x instead. And also, since we're graphing it, we're doing all of this in the y equals button. All right, so let's see what we mean. Let's just use that function we had from our previous video, the natural log of x squared plus 6x times sine of x. And this is a derivative you could take by hand, but if it's on the test on the calculator section, make the calculator do all the work. All right, so let's go over to our calculator. Let's clear the stuff from the previous one. All right, so what we're going to do, we're going to go to y equals, and we're going to type our function. I have it typed from the last time we used this function. All right. And now we're going to scroll down to the next one, and we want to take the derivative of y1. So we kind of saw how to do this already. If we do math, and then 8. My variable I'm taking the derivative with respect to is x, so I just put my x there. The thing I want to take the derivative of is all this. You could type all this again right here, but that's saved as y1. So if I go to variables, my y variables, my functions, then I can just put a y1 in there. And again, before we found like the derivative of this at 1, so I put a 1 here, but now I want to take the derivative of this at every single x and plot it, so I'm just going to put the x there. All right, so I'm going to take the derivative of my function for every single x. That's going to create the derivative function. All right, so let's see what the graph looks like. Again, it doesn't exist for some values, and I have the derivative here. When you're trying to analyze the derivative, it's not normally helpful to have the original function there, so we can turn the original function off by going back to y equals, scrolling over to the equal sign, and hitting enter. So the equal sign is not highlighted. It's not going to graph it, so now I just have my derivative. All right, let's just say, all right, so this is the graph of the derivative. That's enough. Let's just say I was trying to figure out where this graph is decreasing. The original graph is decreasing. That means I'm going to look at the derivative and see when it's negative. So let's say I wanted to figure out when this is negative. I need to figure out where it starts. So I'm going to do that using second calc. And I can find zeros. It's going to start when it's 0, so 2. All right, when you're trying to find a 0, it wants you to put a number just to the left of the 0, a number just to the right of the 0. So I'm going to scroll across to my little cursor is just to the left of that 0. Maybe just a little bit farther just to be safe, and hit enter. Now it says right bound. Now I want to scroll a little bit farther till I'm just on the right, make sure it's a negative number, and hit enter. And then guess, hit enter one more time. And now I know that 0, the place where this negative area for my derivative starts, is 1.82, 0. And I can do the same thing really quickly. 0, left bound, now for this 0, to the left of it, scroll to the right of it, hit enter again to make it guess, and it's 4.789. All right, so now if I remember that value from the first part, that would be when my interval starts. My interval stops there. My original graph would be decreasing because this derivative is negative. All right, so being able to graph the derivative using this y equals section and my end derivative calculation. All right, that's going to give you the derivative graph, and the derivative graph can tell you things like increasing and decreasing. All right, so graphing the derivative by a calculator, are using that y equals section in combination with the way we were finding derivatives earlier.